Alright, oops. Now underneath that, create a 3 by 6 array, come on, in red. Why do you keep going away? So you should have a 3 by 3 array in yellow, and then underneath the 3 by 3 array, I want you to make a 3 by 6 array. They don't need to be connected, but just so you can see both arrays. Right. We've got her 2 arrays out. One is in yellow, one is in red. Parker's got it out too. One is in yellow, one is in red. Hannah's got it. If you're missing a piece in your 2 and you can't make the full array, that's okay. You don't need all the pieces there to know that they're supposed to be there. Remember, that's how we did fast arrays. I want you to try and create a full array. You have the pieces. Just looking at the 2 arrays, how are these 2 similar? We have 3 by 3 at top and a 3 by 6 below. How are these 2 arrays similar? If you want to use some compare words that we talked about, that would be great. Ella? Beautiful. Ella used the word similar, and she said they're similar because they each have 3 columns. Fantastic. How are they similar? How are they similar, Grace? Grace used the word alike, which I like, and she said they are doubles. And she gave an interesting example. You might want to do this with your red counters. She said if you break them apart in the middle, you have a 3 by 3 and then another 3 by 3. So separate your counters of your red ones to be 2 red 3 by 3. I like that Cheyenne's throwing her pencil in there. That works. All right, what is the product of 3 by 3? What is the product of 3 times 3? Right here?
The product of 3 times 3 is 9.
9.
6.
What is the product? Holy moly, that was a really lucky night. What's the product of 3 times 6? The product of 3 times 6. Damien? 18. Huh. How are those products similar? 3 times 3 is 9, but 3 times 6 is 18. How are those 2 things related? Brian?
They're similar because the 3 by 6 has one more group than the 3 by 3.
It has a couple more groups. Ella? True. True. Cheyenne? So 9 doubles. 9 2 times gives you the product of 18. Interesting. Alright, I'm going to give you another hundredths chart. I need you to get out a yellow crayon. So please move your counters back to your main. You're not going to need them right now. I'm going to give you your hundredths chart, and we're going to be coloring in our 3's products. Wait for me before you start coloring, though. Your yellow crayon, we're going to color in the products for the 3's, and we're going to say them as we color them. Now, if you are not a 3's master, you're not a skip counter by 3, that's totally fine. But you better know how to count on. So if you know, okay, the first one's 3, the next one, you're going to go 4, 5, 6,
9.
9.
12.
Alright, you better know how to count, or you know how to skip count. Alright, so we know the first product is what?
3.
3. Color in 3. 3. What's next? 6. Come on. Why don't you want to color today?
Color.
What's next?
9.
What's next?
12.
Next?
15.
Next?
18.
Next?
22. 21.
Start at 18 and count 3 on. 21. What's next?
24.
What's next?
27.
What's next?
30.
What's next?
33.
What's next?
36.
What's next?
39.
Ooh, we're getting not so sure. 39, 38, 40.
42.
Sorry, we're going to go forward. 40, 41, 42. Count on. 43, 44, 45.
48. 49.
45, 46, 47, 48.
50.
49, 50, 51.
54.
54 is going to be next.
57.
Then 57.
60.
Then 60.
63.
63.
69.
Are we starting to see a pattern? Because you guys are starting to get better at this. 70, 71, 72.
79.
Whoa, we're at 72, friend. 72, 73, 74, 75.
78.
What's after 78?
81. 84. 87. 90.
What patterns are we noticing? You just colored in your 3s. What patterns are we noticing? Parker, what are you noticing?
That when you fill it with those numbers, whatever number at the top, it goes down like 2, and it goes
You talking about scooting over each number like this?
yeah, we can do it both ways. Go down.
Oh, good observation. Alright, on the next blank page in your notebook, I want you to write down 2 patterns that you notice. Parker just gave us one. If you go up, to the right or down, you can skip count 2 sections and then the next one's colored in. So in your notebook, one page should say 3s and 6s. That's where our 100 chart's going to get glued in. Don't write on that page. The other page is going to say patterns I noticed with 3s. So Ella said in the one place in our diagonal we're counting down. Which other number do we know does that? That counts down in the ones place each time. We learned a lot of tricks for that one. Ryan?
The 9.
The 9s. Weird. Our 3s and our 9s do the same thing.
Wait, what?
Why would our 9s go down by 1 in the ones place every time? And then our 3s do that too. So again, we have 6, 5, 4, 3, 2, 1. Why would our 3s do that too? 4? Our 3s have the same products as our 9s. $18, $27, $36, $45, $54, $63, $72. All of those products that Ella just pointed out, those are your 9s. Those are your 9s.
Yay.
Pretty cool. What else are you noticing? What else are you noticing? Anything? Georgiana, you're noticing something?
Yeah, there goes.
If we look at our tens, we have 30, 60, 90. That's kind of just like 3, 6, 9. Very similar. By now you should have 2 patterns that you noticed in the 3s written down. We just went over at least 3 or 4. Right? You got another one? Yep. Every third number is colored in. Very good. Diane?
Three.
2 times 3 is?
6.
What is 3 times 3?
9.
9. 3 times 4? 12. 3 times 5?
15.
3 times 6?
18.
3 times 7?
21.
3 times 8?
24.
24. Count on if you don't know. Oh, that doesn't say 24. 3 times 9?
27.
27. And this is an easy one. 3 times 10?
30.
30. We're done?
No.
No. No, we're not done. What do I need to do now? What do I need to do now? Not only what do I need to do now? Slide, which says more than that. Says more than that. Right here.
The commutative property says you can put the numbers in any order and the product will still be the same.
My factors can go in any order, but my product is going to be the same. We've learned that we can do this with multiplication. You can do it with another operation too. What is the other math operation that you can use the commutative property with if you really want to? Most of you do in your head. You don't know that you're doing it. Sam? Addition. Can you do the commutative property with subtraction?
No.
No. Order matters in subtraction. Yeah, that's a big deal. Lucy? Are you talking about in our hundreds chart or in here? In here? Go for it. Another 3 by 2, but this time created in red. So now you're going to have a 3 by 2 in yellow, and then a 3 by 2 in red. Yep. However, we're going to squish it together to become a 6 by 2. Now be careful, because some of you are going to make a weird array. Think about what it has to look like to make a 6 by 2. That's good, Georgiana. Lucy, check your array. That's not a 6 by 2. So now I have a 6 by 2 array. So I had a 3 by 2. And then I squished together another 3 by 2. And now what array do I have? Nathan? A 6 times 2.
because
Huh.
3 plus 3 equals 6.
That looks very familiar. How are my 3s and 6s related? How are my 3s and 6s related? You should have what I have drawn in your notebook. Put your counters up. And you're not going to get them anymore because you consistently play instead of do what I'm asking. No, it wasn't a question. Put your counters up.
The 2 by 6s are related because you might have 6 and then the other one's just going to make the plus, but they double that and make it up.
My 3s doubled up.
Yeah.
Yeah. My 3s are doubles for my 6s. My 3s are doubles for my 6s. My 3s are doubled for my 6s. I did the same equation twice. I doubled it. 3 times 2 plus another 3 times 2 doubled. And I was able to get my 6s. You should have what I have drawn and written in your notebook. What is 3 times 2? What is 3 times 2, Aiden?
6.
3 times 2 is 6. Plus another 3 times 2?
6. 3 times 2. 6 plus 6 equals 12. So the answer is 12.
My 3s are doubled to give me my 6s. Georgiana? Go more. Every third number is colored. Alright, let's see if we can prove that 3s are my doubles on my hundreds chart. Go ahead and get out a blue crayon. So we're going to prove that our 3s are doubles for our 6s. We will know if that's true because on our hundreds chart it'll go yellow and then it's kind of like green blue, yellow, green blue, yellow, green blue, yellow, green blue. That's the pattern we're looking for. If we see that pattern, we know for a fact that our 3s are doubles for 6s. I'm going to get out a green since my markers will change color, but you just need a blue. Alright, first product for our 6s is what?
6.
6. And then what?
12.
12. Thank you, Dylan. And then what?
18.
And then what?
24.
24. And then what?
48.
Mine looks a little junky, but is this proof that our 3s are doubled of our 6s? Did we get the pattern that we thought we were going to?
Yes.
Yellow and then green, then yellow and then green, then yellow and then green. Yes.
Yellow and
Blue, depending on what color it is. This is a product of just 3. This is a product of 3 and 6. This is a product of just 3. This is a product of 3 and 6. And here, quit messing with the crayons. Product of 3, 3 and 6. It skips because I have 3 and then 3 doubled. Oh, that's 6. Another 3, that number doubled. 3 and then 3 doubled. So that's how we know that our 3s are doubles for our 6s. Go ahead and glue that carefully into your 3s and 6s page? Alright, so we're going to fill in our 6s for our multiplication chart. Alright, let's fill it in. 0 times 6 is?
0.
Oh, that was a little sketchy. 0 times 6 is?
0.
0. 1 times 6 is?
6.
2 times 6 is?
12.
3 times 6 is?
18.
4 times 6?
24.
24. Make sure we're adding that. All the other numbers we've had. 24. 5 times 6 is? 30. 6 times 6?
36.
36. Dylan is on fire. He's going to smoke you guys. He knows all his multiplication facts. What's 7 times 6?
42.
Don't you check in the back of the book. 42. Count on. If you don't know, count on. 8 times 6.
48.
48. There we go. 9 times 6.
54.
54. Did we not fill out our 9s?
No, we didn't. We did.
You did, I didn't? Okay, I'll fix that. Are we done with our 6s?
No.
No.
I didn't.
Raise your hand, are we done?
No.
That's not what I said. Raise your hand, are we done? Diane, are we done?
No.
Why?
Because when I said this way, because Distributive Property says we can go anywhere, but the product won't.
I can rearrange my factors, but my product will not change. So now I'm going to go across. 6 times 0 is?
0.
6 times 1 is? 6 times 2 is?
12.
6 times 3 is?
18.
6 times 4 is?
24.
6 times 4 is?
24.
24. Oh, that doesn't look like a 24. There we go. 6 times 5 is?
30.
6 times 6.
36.
Sam, get out of your desk and on your money multiplication chart. 6 times 7.
42.
6 times 8.
48.
6 times 9.
54. 54. That's already filled out. It's 60.
And then 6 times 10.
It's 60.
I'm glad you're pumped back there. Alright, help me fill in my 9s because apparently I missed that. We just talked about how to use our 3s as doubles for our 6s. How else could I figure out my 6s? You're thinking in your head right now. Think about all the strategies that we've learned. Think about the strategies that you use in mental math. How else, besides doubles, which is what we just did today, could you solve for your 6s? Turn and talk to a neighbor and come up with some ways that you can solve for your 6s. Some other ways that we could solve for our 6s. We did doubles with our 3s, but some of you might not be very good at 3s. That's totally fine. What are some other ways? Parker? You can skip count. If you like to skip count and you know how to skip count, go to town. That is a solid strategy. If you can count real quick on your fingers, go for it. Now, when our numbers get really big, is that the most efficient way to do it?
No.
No. But you could. You could. Skip counting will 100% work. It gets to be a lot of counting, but you could. What is another strategy you could use, Cheyenne? Break apart. What would I break my 6 into? Probably a 5 and a 1.
We're 3 and
How many of you are already masters at your 6s? Some of you are. Some of you are. How many of you are masters at 5s? What about masters at 1s? This seems like the most logical strategy. Does anybody remember what the rule is called? I told you what it was called at my small group, but do you remember what the actual name for break apart is called? Gabriella, do you remember?
Part whole.
No, it is like part whole. That's what we talked about. But what the real name is? Do you know, Aiden?
I think I was in training.
Georgiana, do you remember?
No.
All right, turn to the next blank page. It's called the distributive property. Now remember that word property is just a fancy way of saying it's a rule. And we talked about in my small group that this rule, just like the commutative property, you can do in addition, and Gabriella's so right. We know it in addition as part whole, when you break apart one number into two smaller numbers. We can also do it in multiplication. Very similar to part whole, but you're only going to break up one factor. Georgiana. To make two smaller, easier math problems. So let's pretend I wanted to do 6 times, let's say, how about 12? 6 times 12. And I was going to break apart my 6. You don't have to. I know you know that you could break apart your other factor. So we're going to break apart our 6 into 5 and 1. Because I don't really know my 6s all that well, but I am a master at some 5s and I am a master at some 1s. So to rewrite my equation, I'm going to start with the factor that I did not break up. Which factor did I not break apart? Which factor did I not break apart, Ella? 12. So I'm going to start with 12 times 1 part of my 6. What is 1 part of my 6? Courtney? 5. And then we put that in parentheses to say, hey, this is like a mini equation. This goes together. It's the proof. Because you're chill. Plus, start again with the factor that you did not break apart. Which factor did I not break apart? Lucy? The 12. So I'm going to start again with the 12. Now I have to multiply it by the other part of 6, which is 1. So this is my equation. You should have this in your notebooks. 12 times 5. See if you can skip count that. What is 12 times 5? Susie? 60. Plus 12 times 1. Here.
12.
12. 60 plus 12. Good.
72. 72.
72.
Because 2 plus 0 is 2, and 6 plus 1 is 7.
Break apart strategy, otherwise known in the math world as the distributive property. I don't care which one you call it. If you prefer to call it break apart, because that's what it pretty much is, go for it. The mathematical name is distributive property. You don't necessarily need to know that, but it's helpful when someone says, hey, you know about the distributive property? And you go, yeah, actually I do.
Well, if we don't have long hair.
Then I guess you better shake your head really hard. Alright, in your notebook, I want you to do 6 times 7 and 6 by 6 using either your doubles or your fives. Those are the only 2 strategies you can use. So, no skip counting. You can use doubles, which would be your 3s, or you can use your 5s. Those are the only 2 strategies I'm making you use. Grace, what's up?